Well, yeah, welcome to day 2. And look at this student in my period 5 class working diligently on his math homework. Oh, what an inspiration for all. Well, today we're doing a couple more complicated questions with factoring. So remembering some of our things we learned yesterday about the zero property of multiplication, where we set these quadratic equations equal to 0 and then factor them. So let's try that. Let's subtract x squared from both sides. Add 3x, subtract 16. Add 3x, subtract 16. Again, we're just going to set it equal to 0 and solve. 2x squared minus 1x squared is x squared. A negative 12x and a positive 3 give me a negative 9x. A negative 20 and negative 16 is a negative 36. And that equals 0. Set equal to 0. Factor it. It's a trinomial, no GCF. I need things that multiply to give me 36 and combine to a negative 9. How about a negative 12 and a positive 3? And then if I do my zero property, not 10, but 12. My zero property of multiplication, I know from here that x is going to equal 12 and x is going to equal negative 3. Very nice. And again, as long as you use the zero property and write down these equations, then you're in a good spot. You can just jump down to x equals 12 and negative 3. So a little more complicated here. Do you think you can distribute on the left side and then set equal to 0 and solve? Take a minute, give it a shot. Alrighty, so if I do my distributive property, I get y squared. I get a minus 3y. Whoops, y, not x. Y because the variable is y. That's y. I get a positive 2y. And I get a negative 6. And that equals 8y plus 4. OK, now I got my quadratic equation. Set it equal to 0. I get 0 over here. Now let's see. I got to combine a bunch of y terms. So I got a negative 3y and a positive 2y. That's a negative 1y. And when I combine it with a negative 8y, I get a negative 9y. And negative 6 minus 4 is negative 10. Let's solve this by factoring. No GCF. Y times y is y squared. I'm thinking numbers that multiply to 10 would be like a negative 10 and a positive 1. Y minus 10 equals 0. Y plus 1 equals 0. So my two answers are y equals 10 and y equals negative 1. Hey, don't forget this is one you could check as well. Plug in 10. Plug in negative 1. When you plug in 10 for every y first, you should get the same answer on both sides. Plug in negative 1, same answer on both sides. Yep, you can check all these. Let's keep playing a little bit. Ooh, do you remember how to square out that squared binomial on the left side? Give it a shot. So first of all, when we square x plus 2, after we do our distributing, we're going to get x squared plus 4x plus 4. You might remember that perfect square trinomial, right? Distributing on the right side gives us a 7x plus 14. Hey, this should look familiar now. Set equal to 0 and factor it. Keep my x squared positive. So now we're getting x squared minus 3x minus 10 equals 0. When we factor that, it's going to factor to x minus 5 times x plus 2. Remember, the 5 times 2 gives us the 10, and it also gives us the negative 3. My zero property says that then these two expressions must equal 0. So we'll get one answer of positive 5, one answer of negative 2. So the zeros of the equation are positive 5 and negative 2. Sorry about that. Dropped my microphone. All right. Now, this isn't really a quadratic equation, but we could do some factoring here. So if I want to solve for x, I want to move all my variables to one side. I want to go with my x's on the same side. So I'm going to subtract 4x from both sides. And maybe I'll also add 3b to both sides. Okay, because I want to solve this equation for x. So I want to get the x's by itself. Now, I don't have like terms here. So I'm going to leave this as ax minus 4x. Well, I kind of have like terms, but we'll talk about it in a second. And the same thing over here is that I have a 3b plus 2b. And I'm just going to write that down here for now. Because 3b plus 2b is 5b, because we can add the 3 and the 2. But likewise, can we do anything on the left side? Well, the reason why we got 5b is because in this 3b plus 2b, isn't our GCF equal to b? So if we take the b out, we're left with 3 plus 2. And we can add 3 plus 2 together to get 5. So let's do the same thing on the left side. Notice that my GCF on the left side is x. So if I factor out an x, I'm left with a minus 4. And now I have x times something equals 5b. So let's divide by that something. The a minus 4's cancel over here. So it's not a pretty expression, but we get 5b over a minus 4. Not bad. So yes, we can use some GCF factoring to help us solve an equation for x when there's two x's on the same side. Let's keep going. Check out this Regents question. Given that a is greater than b, let's solve for x in terms of a and b. So let's proceed like before. We're going to do our distributive property. So we get bx minus 3b, greater than or equal to ax plus 7b. This looks like what we did before. So let's get all our x's on one side. Let's subtract ax. So can I move that over a little bit? There we go. And let's add 3b to both sides. So I'm going to get bx minus ax equals, and let's see if I combine 7b and 3b, I get 10b. So again, take a look on your left side for a minute. Can you tell that there's a GCF of x? So if I factor out that x, I'm left with b minus a. Whoops, keep forgetting that symbol there. So now I'm going to divide by b minus a. Now you might remember something here. You might remember that when you're dividing to solve an inequality, you got to wonder if you're dividing by a negative number as to whether or not the inequality sign gets switched. So remember way back in the beginning of the problem, it said that you're given that a is greater than b. If a is greater than b, that means that b minus a is going to be less than 0. Think about it. Let's say that a equals 6 and b equals 4. Then 4 minus 6 is a negative number. So I have to switch the direction of my inequality sign because I divided by a negative. Holy, that's a tricky question there. Hopefully that doesn't appear in our Regents exam. So think about this other more complicated factoring, if you will, or even better, factoring these last two where you're solving an equation for x with letters, other variables in it, by doing some factoring.